Hello guys, good morning, how are you? I hope you're doing good. Okay, today in this video we're gonna start working with the series and parallel connection in electrical circuit. Okay, we're gonna see the differences between the two type of connection and how to work out the different circuits. So normally we have so far we've been working with circuit with maybe just one element like a lamp, but this is not real. In real life, we always connect more than one element. For example, in our houses, we can find lamps, washing machine, the fridge, and there are two main ways to connect load devices. Okay, the first one is series connection. It's the easiest way to connect because it's just one element after the other in the same cable. Okay, you have here an example of some with three lamps. And we have parallel connections. Parallel connection in which they are in different branches. Okay, it's more difficult to connect, but we will see that it has more advantages. So in parallel connection, the elements are connected both to the positive and the negative of the battery. As I say, series connection is easier to connect, but we have a problem. The problem is that when we have a broken element or a lamp is blowing out or whatever, the whole circuit stops working. Why? Because the current is interrupted. There is no connection between the other elements with the battery. So this is the main issue with the series connection. However, in parallel connection, we have a broken element. The other elements will continue working because they remain connected to the battery, as you can see in this circuit. Okay, for calculation, from now, we won't work with symbols anymore. Even if we work with lamps, motor, buzzer, or whatever, to calculate values like the current or voltage, we will always use the symbol of resistance. Why? Because for the electricity, it doesn't matter whatever we have connected. For the electricity, everything is just a resistance. It's an opposition to the current flow. So that's the reason why from now we will use these two symbols just for calculation instead of using the symbols of load devices. Okay, we can find these two. So far you've been working with this, but you can find this as well as a symbol for the resistance. So, for example, we have a circuit like this with a lamp, a motor, and a buzzer. We will represent it like this for calculation. We will name the resistance like R1, R2, R3. Or maybe you can find it like this with this symbol. It's exactly the same. Okay. So main differences in series and parallel connection. When you have these two examples. Series connection, as I say, you have the resistance connected one after the other in the same cable. And in parallel we connect one to the battery and then we connect another in a different branch. This is series. In series connection we have the same current going through all the elements. Okay, all the elements have the same current because there is no other way for the current. While in parallel connection the current splits up in different branches. Okay, so as I said, if we have a problem like a broken resistance, the current will be zero because we have an open circuit. While in a parallel connection, the current will be zero in the broken element, but we will have a current different from zero in the other branches. Okay. So let's see how to calculate the different parameters or variables in a series circuit. Okay, you have a summary here. Imagine that you have a circuit with three resistance. So we have resistance R1, R2, R3. We have the total current that is the same because there is no other way for the current. We have the voltage, the total voltage, and the resistance, the equivalent resistance or the total resistance is very easy to calculate. We only have to add the number, the three resistance we have. Okay. To work out or to calculate the current, we only have to use the Ohm's law. We only have to divide the voltage, the total voltage, divided by the total resistance that we already calculated here. The current through each resistance is very easy because, as I said, is equal to the total current. And the voltage, this is something we will calculate later. is the result of adding all the three. Okay, there is a voltage drop in every resistance. This is something we're gonna see later. So imagine that we have this circuit, this example with these three resistance, which value are 2, 3, and 1 ohm. And the first step, we had to use the formula to work out the total resistance. We only had to add the three resistance, and now we only have to replace the numbers. It's very easy. The first resistance is 2 ohms, the second is 3 ohm, and the third one is 1 ohm. So the result is 6 ohm. So we can replace all these three resistance by one, which value is 6 ohm. So to work out the current, we only have to use the Ohm's law that we already know to calculate the current that we know is the result of dividing the total voltage, that is 12 volts, by the total resistance that we already calculated, is 6 ohm. So 12 divided by 6, the result is 2 amps. So 2 amps is the total current. And now we know that the current through each resistor is the same, because as I say, there is no other way for the current to go. So the current through each resistor is equal to the total one, and is 2 amps. So as you see, it's very, very easy. Okay, now we're gonna calculate what is the voltage drop. Okay, you have here the result, but I'm gonna show you how to get to this result. As I said, the total voltage is the result of adding all the three, but let's stop to make sure that we understand the difference between voltage and electric current. Okay, so we go to the definition. The voltage is the difference in charge between 2 points. For example, you have a battery with 6 volts. It means that I have 6 volts here, and in the negative terminal I have 0 volts. Okay, next to the positive I have 6 volts and 0 volts after the resistance. And the current is the number of electrons through a conductor over a period of time. Okay, it's like a motorway. If you count the number of cars going through a motorway, this would be the current. Okay, you have this example. Imagine that this is a circuit. These are the electrons. This is the battery. Okay, the battery is pushing the electron. They are full of energy. Okay, they have the maximum voltage here. They're going through a wire, a conductor made of copper with no resistance. We consider a cable has no resistance, but when the electron or the current is getting to a resistance, the electrons are losing their force, they're losing their energy. So they start with the maximum voltage here, and at the end they have no voltage at all. Okay, so the current is the number of electrons through the wire. We count the number of electrons, that would be the current. So we have the same current here, same current here, same current here, because yes, we are just counting the number of electrons, while the voltage is like how strong or how full of energy the electrons are. So you have here the example with 12 volts. Imagine we have a battery with 12 volts. So the electrons have 12 volts here, but after the resistance they're really tired, they have no more energy, so they have 0 volts. So voltage drop. So imagine that we have a case with 3 resistance in series. So we have the electrons here full of energy. Imagine that they have 12 volts. After passing by this resistance, they are losing energy, not all the energy. They only lose all the energy when they get to the negative terminal here. So they have more energy, and so they spend this energy in the second resistance. Okay, and then after the third resistance is when they have just 0 volts. Okay, there is a voltage drop. So imagine that this is the circuit we have with 3 resistance in series, and we have 12 volts here. They are losing 4 volts in this resistance, so they have 8 volts now. After this resistance they only have 2 volts, and after the final resistance they have 0 volts. They always get with 0 volts to the negative terminal. Okay, you have a summary here, but be careful because the current is the same, because as I say, the current is the number of electrons that are going through the conductor. So if we have 2 amps here, we have the same 2 amps here, we have the same 2 amps here. So it means if we have 2 amps of electrons leaving the positive battery, they're gonna get 2 amps of electron to the negative of the battery. Okay, so you shouldn't confuse what is the voltage. Voltage is the energy they are losing in the way to the negative, and the current, that is the number of electrons. It's the same if you compare with this car, with a car, for example. Some cars are leaving the city, and they are full of petrol, and as long as they are going by a motorway or they are crossing a city or a road, they are wasting the petrol. So when they get to the petrol station, they have no petrol, they have 0 volt, they have no energy. But the cars are getting to the final destination. So the number of cars will be the current, and the petrol they have would be the voltage. So now we can use this to work out the voltage of every resistance. And how do we do it? It's very easy. We only have to apply the Ohm's law to every single resistance. So in every resistance, we know that if we multiply the current by the resistance, we get the voltage. How do we know the current? Because we already calculated the total current is 2 amps, is the total current, and it's the same as every single current. And we have to multiply it by every single resistance. In this case, for the first resistance, we multiply 2 amps by 2 ohms, and the result is 4 volts. Okay, so there is a drop of 4 volts between this point. We have 12 volts, and now we only have 8 volts. So next resistance, we do the same. We multiply the current and the resistance. So now we have again 2 amps of current, and now we have 3 ohms. So 2 by 3 is 6 volts. So we have a drop of voltage of 6 volts between these 2 points. Finally, in the last resistance, the value of the current is still the same, is 2 amps, and now the resistance is 1 ohm. So we multiply is 2 volts. So the total voltage is 2 plus 6, but plus 4 is 12 volts. And finally, in the last point, we have no more voltage. Okay. In coming videos, we will learn how to calculate in parallel connection. Goodbye, guys.